Hey guys, it's Mr. Wolfe here, and I'm going to be going over the third part of our target one on momentum. And these are going to be more extension problems. So we're going to be looking at a problem of bouncing. We're going to be looking at a problem of comparing an object colliding with a haystack versus a wall. And then finally, the change in momentum between a car and a truck. So let's look at our bouncing scenario first. And so for bouncing, let's say we have like a 1 kilogram basketball and it's traveling to the court and it bounces back up. All right, how would we find the change in momentum of this? And let's just say our velocity is going to be negative 20 meters per second here because, right, it's going downwards and it's 10 meters per second going upwards, positive 10 meters per second because it's going upwards. All right, so how would we find this change in momentum? We would actually just use the same equations that we had been using here. But what tricks students up on this is the fact that we have this changing direction right here. So let's just start off by writing our equation. Our change in momentum is equal to mass times my change in velocity. So my change in momentum is equal to my mass, which is first 1 kilogram, and then my change in velocity. All right, I would recommend just using our change in velocity equation here, just to make sure we have everything right. So my change in velocity is equal to my final minus my initial. So my final velocity here is going to be 10 meters per second minus my negative 20 meters per second. So when you do the math on this, your change in velocity ends up really being 10 plus 20 meters per second. So your final change in velocity is equal to positive 30 meters per second, right? This is the toughest part of the bouncing problems. Once you get this, you're fine. It's just putting in numbers like we did up here. And so our change in velocity is 30 meters per second, and our change in momentum ends up being positive 30 kilogram meters per second. All right, let's look at our second problem, which is why would you rather crash into a haystack rather than a wall? And it seems all very intuitive to us that we would much prefer this haystack over the wall. But in terms of physics terminology, why is this? What's going on with these variables that causes you to essentially experience a lesser force when you hit the haystack? Well, first let's look at our relationship between force and time. They're on the same side of our equal sign. So force and time are going to be inversely, hopefully you guys can see this, inversely related. And let's just kind of like put a circle around that because this is important. All right, so with this in mind, let's look at this problem right here. And so here we have a car, and let's say it's the same car, it's going at the same velocity, and if that's the case, whether you hit the haystack or you hit the wall, you're going to zero, like you're going to have that same change in velocity going to 0 meters per second. So interestingly, both scenarios have the same change in momentum. I read another word for change in momentum is going to be impulse. All right. So what's going to be different is we have to look at the relationship between force and time. For this haystack, the amount of time that this force is being applied on this car is a pretty long amount of time. And so that's represented by that larger T right here. And so if time goes up, that means my force is going to go down. And if we look at the car hitting the wall here, that force on the car is going to be applied really, really fast. And if that's the case, if our time's going down, that means our force is going up. And so you're going to experience a much greater force. So why would you rather hit the haystack rather than the wall? Well, they both have the same change in momentum, the same impulse. But the haystack applies a force for a greater amount of time. So the force is not going to be as much. It's going to decrease. All right, and let's look at our last problem. A car and truck collide head on. How does the force they experience, the change in momentum, the impulse, and the change in velocity compare to each other? So let's first just look at the force they experience. And at first glance, everyone thinks that the car experiences a much greater force than the truck. And this is going to be Newton's third law, and we haven't talked about this yet, but if we go back to gravity, we hit it a little bit. So remember that the force you exert on the Earth is actually the same amount of force that the Earth exerts on you. So the force on car is actually going to be equal to the force on truck. And if this is a really tough concept to get down, so just keep that in mind. And we're not really going to hit it entirely until target 2. So I'm even just going to write here, this is a tough concept. All right. Wait until target 2, where you could really fully digest this idea. All right, but just take my word on it for now. The force on the car is equal to the force on the truck when they hit each other. All right, so when they hit each other, this force, this equal force, is going to be it's going to be applied for the same amount of time. How could it not, right? So the time of contact for both is the same. So force and time is what you use to calculate your change in momentum, and if the force and time in both scenarios are going to be equal, well then their change in momentum, let's just say change in P, is going to be the same as well, interestingly. And then how does their impulse compare? Well, the change in momentum is the impulse, so the impulse is also going to be the same for the car and the truck. And then finally, how does the change in velocity compare to each other? All right, now we're going to have a difference because we know that our change in momentum is going to be the same for both objects. And I'm just going to show that by having my change in P here. And we know that the mass of the car is going to be tiny, so I'm going to represent that by a really small mass. And the mass of the truck is really big, so I'm going to represent that with a really big M right there. So in order for the change in momentum for both to be equal, this change in velocity for the car just has to be bigger, right? Because it has such a small mass. And since this truck has such a large mass, its change in velocity just has to be smaller. All right, so the change in velocity, I know there's not a whole lot of room here, is going to be greater for the car compared to the truck. And really, this is the only difference we have here. Impulse, change in momentum, the force on the car and the force on the truck, these are all going to be equal to each other. And this, like right here, this is a tough concept to get down. And so we will definitely work with this more and more, especially when we get to target 2.